Hello. So we are moving on to our very last lesson of this unit, which we've talked about already, means your test is coming up. So this very last lesson talks about the linear regression line. And I do want to start out by saying that this is different than your line of, your line of best fit by eye. Okay, so these are different. And I noticed that some of you who already know how to find the regression equation were using this as opposed to finding your line of best fit by eye on quizzes that I've been handing out to you. So your line of best fit by eye is what we've learned so far, and that's where you have to find the mean point, and then you have to just by eye kind of like figure out where exactly does this line go so it follows the pattern of the scatter plot. Your linear regression is a regression equation that your calculator does give to you, and it's right next to where you would do your stat calculations before. So it's a very, something you've probably already seen, and the steps to get to it actually aren't that much more than what you have been doing so far. Sometimes it's referred to the least squares regression line, and it's a very weird way to refer to it if you don't know what they mean by a least squares regression. So just very quickly, I'm going to talk about what they mean by that, because we're not going to really go in and talk about how to calculate the squares or anything, but if they refer to it as it, I want you to kind of have a visual that goes along with it. So we've got a coordinate plane. I'll draw an approximate scatter plot. Okay, and let's say that I have drawn in a line of best fit by eye. I found the mean point, and then I went in and I drew this regression line. So this guy right here is your line of best fit, or what we call the regression equation. And in this case, the equation is the equation of a line. So when we graph it, it is a line. Okay, so when we have drawn in the regression equation, we want to talk about, and we have talked about, the distance of these points away from that regression equation. And we want to minimize that distance away from the regression equation as much as possible. Now, when we just deal with the linear distance of these points to this line, the math gets complicated. It doesn't quite work out. So we talk actually about the area that is between. And what that looks like is something like this, is that we've got these, I'm not very good at eyeballing it, but we've got these squares that connect a point to the line, and all of these data points can have a square be drawn to represent the area of that point from the regression equation. Kind of sort of getting the idea. I do want you to try and draw out this idea on your own. So all of these data points that we have, as a result, then have all of these little itty bitty squares that really just represent the distance of that point away from our regression equation. And the goal with the regression equation is to minimize square area. In other words, we're trying to get those squares to be as small as possible when we're finding out our line of best fit. And it's because those squares represent the shortest distance in order for it to mathematically work out. And so there's ways, if you're interested, if you want to go online and look up a least squares regression model to play around with, there's ones that you can go on and you can just like put in a scatter plot, and then it puts in a regression equation, and you can play around with the regression equation and see these squares get bigger and smaller. So that's the idea of the least squares regression line, is that it's a regression line that then takes all of these square distances and makes it the smallest possible total area of squares. So that's what we mean. In other words, we just mean the linear regression that you can find in your calculator, but that's the terminology there that I'm sure you will see further on in your calculations. Okay. First example, in Zambia, a staple of the diet is ground maize, which is corn, known as mealie meal. In one market, bags of mealie meal are priced as shown in the table. Prices are given in Zambian kwacha, which is written like that. Explain why it is appropriate to use a linear model for this data. So there are two things that we need in order to justify using a linear model here, and they both need to be done on our calculator. So what I would like for you to do first is make a new document. I would like to insert a data and statistics page. Oh no, I lied. I would like to insert a list in spreadsheets. My bad. We want to list in spreadsheets. And I'm going to put in all of these numbers. So I'm going to do 5, 10, 50. Please make sure you're following along. I will be asking you questions. So put these in your calculator. Okay, so I've entered this into my data, and I want to see it as a scatter plot, because a scatter plot will be the quickest way to tell me whether or not it looks like it's going to be linear. So remember, in order to, I need to store each of these guys. So I'm going to do var store. And I'm going to store this as x, var store, and then I'm going to store this guy as y. And then I would like to insert a graph to the side. So 4 and 4 again. And then I would like to insert a scatter plot. So I do menu, graph, and then scatter plot is number 6. And then in order to pull up what I've stored as x, I just need to hit var again and click on x. And then hit var again and click on y and plot it. Last thing I need to do is make sure that my zoom is at a fit, and then it comes out like that. So you get a scatter plot that looks linear. So the first thing why it's appropriate is that the scatter plot, the data, appears linear in a scatter plot. Okay. That's good. So if it appears linear, we can say, I'm assuming it's linear. It's always good to have backup. I'm going to go back to my spreadsheet here, and I'm going to try and find R. I'm going to find R. So I go in menu, statistics, stat calculations. I want to do 2 variable statistics. My X list has been stored into the A column. My Y list has been stored into the B column. Frequency of 1, so I don't need to worry about that. And I can put my results into column C because there's nothing there. Press enter. I go down and find R. And I get that R is equal to 0.3 sig figs is going to round to 0.999, which signifies a very strong positive linear association, right? So those two things together tell me, yes, this is linear. It would be appropriate to find a linear regression or a linear model for this data. Okay, it then says to find the best fit linear model for this data to predict the price given the mass. Use P to represent the price and M to represent the mass. I'm going to first figure this out with the X and Y idea and then plug in what P and M go in for. Remember that X is what our input was up here, Y was what our output was. So the mass is going to be your X and the price is going to be your P. And so that's all it's saying is like, hey, when you're done, just make sure instead of doing Y equals, do P equals. That's it. All right, so regression equation. What we need to do is go through almost the exact same steps that we would to do our 2 variable statistic calculations. So what I'm going to do is go back over here just because I like to have the cursor there when I start to do my calculations. But we're going to do statistics, stat calculations. Instead of moving directly into our 1 variable, 2 variable, I want to move to linear regression, which I'm sure most of you have seen at this point. Notice that there are two linear regressions. You can use either linear regression, just as long as you notice that the difference between them is that one of them has your x term in the front and one of them has your x term in the back. The general idea of your linear equations is that it gives you a slope and a y-intercept. And remember that the number that's multiplied to x is always your slope. So for the first linear regression, it's going to be m. Whereas for the second linear regression, it's going to be b. It's going to be your slope or your gradient. And then b on this guy would be your y-intercept, whereas a over here would be your y-intercept. So that's all the difference is, but you just need to make sure to flip where your orientation of it is. I would recommend just sticking to 3 because it's what you know, mx plus b, but it's not that big of a deal. All of this to say, I would like for you to calculate your linear regression. So I'm going to do the number 3 here. My x list is still in column A. My b list is still my y list is still in column B. It says it's save regression equation 2, and it's saving it right now automatically to F1, which means that it's being saved in my graph page. That's just to the next page. It's automatically saving it into F1, which means I can just go and click enter and it will graph it on my scatter plot on the next page, which is really cool. And I'll show you how to do that in a second. So we do like that we're going to store it. Frequency list is 1. Careful with the results because I've already calculated my R with this guy. So column C and column D are now taken up with my two variable statistic calculations. So I need to go to the next column, right? So I've got A and B filled with my X and Y. And now I have C and D filled up. So now I need to make sure that everything goes into column E. Make sure to scroll up. I sometimes forget, I'm like, where did it go? It's because I didn't scroll up. And so then this is how they give you the regression equation. It reminds you, hey, this is the form right here, mx plus b. Here is your m, and here is your b. So if m is equal to 2.67 and b is equal to 8.14, 3 sig figs, your equation is y equals 2.67x plus 8.14. And now I just need to do my final tweak on this, so it's just to make sure that it's in terms of p and m. And since p is really my y, I can now do p, and I can even do p of m equals, because we know it's a function, p of m equals 2.67 times m plus 8.14. And that is my final regression equation in terms of p and m. So this is different than your line of best fit because your line of best fit follows this idea of the mean point and then kind of visually piecing it out. And sometimes on the IB exam, they'll ask you to do the line of best fit by eye as opposed to the actual regression equation. So they're trying to make sure that you understand that there's a difference here between the two.